Welcome to Stories for Sleep, where science is not dry numbers, but the gentle whispers that lead your mind into sleep. Tonight, we will step into a special land of knowledge, where even how great, clever, and patient science is, it still stands before unsolvable mysteries. Perhaps that is also why you have trouble sleeping. Your mind is always looking for answers, always wanting to understand, always wanting to grasp. But there are things even scientists can only watch in silence and admit we do not know. And strangely, that very not knowing can be beautiful enough to lull the soul. Brains that have not decoded themselves. A universe so vast we cannot know where it ends. Where consciousness comes from. What dreams want to say. Why there are strange things in nature that no one can explain. Lie down, slow your breathing, and let these gentle mysteries take you on a journey both scientific and dreamlike. Tonight, we are not looking for answers. We are only learning to sleep peacefully among the unexplained. Why is there something rather than nothing? We are often told that the universe began from a single moment, a singular point smaller than a speck of dust, hotter than any furnace, and suddenly it bloomed, creating space, time, energy, matter. But when we ask, what caused the Big Bang? All of modern physics can only reply, we don't know. Not knowing, but still searching. Uncertain, but still observing. And you see, there are questions not meant to be answered, but to remind us of the softness of knowledge. It is not a knife that slices through the dark, but a small flame that lets us step a little further. The narrator invites you to close your eyes. Imagine the universe at its primal moment, when everything we know, mountains, rivers, light, memory, you and I, all lay within an invisible space, unnamed, colorless. Does nothing truly exist? Or is nothing merely something the human mind has not touched? One of the most beautiful mysteries of science is that time may begin with the Big Bang. If so, asking what was before is like asking which way is north of the North Pole. Some scientists believe the universe may have once contracted, then popped outward like a great breath. The name of this hypothesis is poetic, the Big Bounce. The universe, like a heart, contracts, expands, lives, rests, dims, brightens, repeats like an eternal beat of which we hear only one beat in our lifetime. There is also the hypothesis that the Big Bang is just one of countless explosions happening in countless universes. Each universe inflates, lives, dees in silence, like bubbles rising then merging back into the ocean's surface. If that is true, then the night you are lying in the calm of your breath, might be a tiny moment in a reality vaster than imagination. 13.8 billion years is a familiar number, the figure humanity has been quoting for decades. But then, exceedingly bright and ancient galaxies in James Webb data have puzzled scientists. Maybe the universe is much older than we thought. Tiny galaxies that existed when the universe was still very young have been found in a state more mature than theory allows, as if we met a child, but with the eyes of an old person. This opens the possibility. The universe did not only expand once, but has undergone many cycles: birth, expansion, contraction, then rebirth. A vast loop so large that all our concepts of age are only small waves on the sea. And in that moment, when you listen, you may feel that the age of the universe is like your own age, both very long because it holds memories, and very short because it passes like a breath. Space appears empty. But if empty, how can it carry billions of galaxies? How can it bend time? How can it slow light when it passes massive objects? Science has discovered that Space is not a hollow void. It is a soft fabric, constantly vibrating, with hidden energy at every smallest point, quantum fluctuations, appearing and vanishing. Space breathes, literally, and so does time. Time runs faster or slower, depending on where you stand. Near a black hole, one of your minutes may be hundreds of years for someone else. Time, in essence, is the rhythm of space. When you lie down and close your eyes, you are drifting on that fabric of space, a tiny being wrapped in the embrace of an invisible music. Science can only explain about 4% of the universe. The rest, dark matter and dark energy, are completely mysterious, unseen, untouchable, yet govern most of the motion of galaxies. We live in 4% of the light and are held by 96% of a gentle darkness that science does not yet understand. And here the narrator lowers their voice, as if sharing the most intimate secret. Perhaps the true nature of the universe is not to be understood, but to be felt. And why? Does time flow only one way? Not to be decoded, but to make our hearts know humility and wonder. The mysteries of the universe are not things to frighten us. On the contrary, they are like a soft blanket draped over the tiredness of the mind. In a world where we must always know, always explain, always be sure, it is a relief to remember that not knowing is natural, not understanding is beautiful, and sometimes mystery is what rocks us to sleep. The universe took billions of years to become as peaceful as it is now. So have you. You have passed through a long day. Now you are allowed to breathe, to settle, to have no answers, because it is precisely the space between questions that gives birth to the gentlest sleep. One of the most serene paradoxes of science is almost all physical laws do not care about past or future. The Schrödinger wave equation can run backward. Maxwell's equations too. Even the descriptions of planet or electron motion, in theory, can be run backward without inconsistency. If the universe is like a piece of music, then mathematically, it could be played in reverse and still be in rhythm. Yet life never returns. A leaf that falls from a branch never jumps back to its place. A droplet of water that shatters never reassembles into its original shape, and a memory once past can never be re-experienced with the pristine freshness of that moment. There is one law that breaks that perfect symmetry. The law of entropy, the degree of disorder. The universe always goes from order to disorder, from neatness to mess, from concentration to dispersion. That is why time has direction, not because physics forbids reversal, but because the universe does not choose that. Like a river always flowing to the sea, not because it cannot flow back, but because nature does not demand it to. Entropy is a word that scares many, but in truth, it is very much like everyday life. When you tidy your room, everything is neat. But in just a few days, clothes fall askew, books lean, and the room bears the look of a long, tired day. No one made it messy. It becomes disordered on its own. Space is the same. Time is the same. Entropy is the same. Time is movement toward greater disorder. That is why coffee and milk mixed together cannot separate back into two layers. Smoke spreads, but does not gather back. New memories cling to old ones, then gradually fade, and your youth flows in one direction and never returns. Not because you are weak, not because time is cruel, but because the universe is following its own rhythm. Some say, if time could reverse, pain could vanish, and what is beautiful could live forever. If time reverses, nothing truly happens. Stories would freeze like stones. Because time goes only one way, we know we exist. We know what is precious. We learn to love. We learn to cherish the company of others. because they, like you, pass through life only once. The direction of time is the foundation for all hope and all memory. Without it, there would be no us. Our brain, with billions of connections, is designed to record changes. You don't remember the blue sky from 3,000 days ago, but you remember the sudden rainy evening 2 years ago. We record surprise, and surprise can only happen in the future. If time flowed backward, all surprises would vanish. Every story would have only one script. We would have no memories, no choices, no freedom. Can you feel it? The one way of time is not a burden, it is a gift. Imagine, the tree would not know to grow. Water would not evaporate to make rain. DNA could not replicate. The body could not heal. And in this passage, the narrator almost whispers, "Your heart could not beat." Because a heartbeat is a motion from low to high, from contraction to relaxation, from order to disorder and back to order. Without the direction of time, a heartbeat could not be complete. So, every time your heart beats, it is proof that time is protecting you, giving you the chance to experience this world a little longer. The deepest reason time flows one way is so that things in the universe can change, so that a child grows, an elder tells stories, memories form, pain is healed, and sleep draws near. Time only moves forward, but that is not frightening, because with each step it takes, the universe opens other mysteries, things science has not yet touched. And so the journey continues, not running, not searching, but drifting, soft as a dream approaching. And if time is something we cannot hold, is there anything else in the universe we never see? All you have ever seen, stars, planets, light, your body, and even the breath in the night, makes up only 5% of the universe. The rest, 95%, does not shine, does not reflect light, does not absorb light, does not emit any electromagnetic signal. It is invisible, it is silent, it never touches your eye, but it holds the whole universe together, like the love of someone you do not see, yet which keeps you steady every day. A galaxy like the Milky Way, round, graceful, spinning through space like a giant dancer, in fact, could not exist with only the amount of matter we see. If there were only stars, planets, and cosmic dust, gravity would not be strong enough to hold everything in as the galaxy spins rapidly. Everything should have been flung outward, like droplets cast off a spinning wheel. Yet they do not fly away. They remain there still, beautiful and rounded. That can only happen if something exists that is massive, strong in gravity, enveloping the whole galaxy, but completely invisible. That thing is dark matter. It does not shine, so we cannot see it. It does not collide with light, so light passes through it as through the night. But it has weight, and its weight keeps the galaxy in its embrace. Dark matter is the backbone of the universe. You do not see it, but if it vanished for even a second, the whole night sky would collapse like dust falling away. What makes dark matter poetic is precisely the not knowing. There are hypotheses that it is a new particle, never detected, WIMPs, axion, neutralinos, names sounding as if stepped out of a physics myth. There are hypotheses that dark matter is not a thing, but a flaw in our understanding of gravity. There are hypotheses that dark matter could be dead galaxies, too dim to see. Some believe that dark matter comes from another dimension, the golden sun of a parallel universe, shining here as gravity, but carrying no light. The name dark matter is merely an admission that we do not understand. It is a beautiful confession. a deep humility that counters the pride of knowledge. If dark matter draws the universe together, dark energy does the opposite. It pushes everything apart, not gently, but day by day, ever faster. When scientists measured the expansion rate of the universe, they expected it would slow down because gravity would pull it back. But what happened stunned them. The universe is accelerating, as if you throw a stone upward, and instead of falling, it flies faster and faster, forever. To explain that, science had to name what pushes the cosmos: dark energy. That name does not reveal its essence. It only states the fact. We do not know what it is, only that it is there, as if afraid to disturb the universe itself. Perhaps dark energy is the breath of space. Perhaps it is the pressure of other dimensions. Perhaps it is something we have not yet imagined. And perhaps it is the way the universe ensures things never stand still. They are opposites. One holds, one pushes away. One hidden in darkness, one spreading in the void. One like hands holding a galaxy, one like wind blowing galaxies apart. But both are invisible. Both do not shine. Both are ways the universe whispers to us that you do not see everything, but the invisible can still hold you. Hearing this, your body lightens a bit, like someone placing a hand on your shoulder in the dark. You do not see them, but you know they are there. Try to imagine you are looking at the night sky. What you see is only 5%. Starlight, planets, nebulae, the glow of galaxies. The remaining 95%, unseen, untouchable, not directly measurable, is still moving, supporting, and shaping all the space around you. You sleep in a dark room, but the universe is darker still. Not a terrifying darkness, but the kind, gentle darkness of things not yet understood. A fast darkness, but as soft as the sky before dawn. Dark matter and dark energy make up 95% of the universe. Things we don't see, but that are always present, like the deepest parts of your own soul. And if most of the universe is invisible, what else in this world, and inside you, also exists quietly like that? But if 95% of the universe is what we do not see, what makes the remaining 5% able to create light, planets, life, and you? For a universe like this to exist, physical constants must be set to astonishingly precise values. Not a bit bigger, not a bit smaller, but exactly the numbers we have, like a guitar string, tuned so that if tightened or loosened by 1%, the tone would shatter. The universe is the same, just a tiny change, and life would never appear. If gravity was stronger by only 0.00000000000000000000000000001, a little, the universe would have collapsed immediately after birth. If it were weaker by that same minuscule amount, everything would be so diluted that stars or planets could not form. The electromagnetic constant, the strong nuclear force, Planck's constant, the speed of light, all seem set at a golden point, a fragile balance almost absurdly fine. This is not evidence of a divine hand. This is evidence that we do not yet understand the universe. But it is precisely that not understanding that makes the universe gentle, beautiful, and makes one want to lie down and listen further. Is the universe tuned for life? Or did life appear only because the universe accidentally happened to fall into these rare numbers? Or are there countless other universes with different constants, and we exist only in the universe where life is possible? Maybe we are just a story, told at the right time, in the right place. If electromagnetism were slightly stronger, atoms would be unstable, the universe would be a chaotic plasma. No water, no carbon, no chemistry, no life. If the nuclear force were weaker by 1,000th of a thousandth, the sun would never burn steadily. It would either explode immediately or flare briefly then die out. If the speed of light were different, space and time would no longer be compatible for forming planets. If dark energy density were just twice its current value, the universe would expand too fast for any galaxies to form. All of these are just a few among hundreds of fragile conditions. Oh, existence, quite literally, is a mathematical miracle. Multiverse, a multi-dimensional universe. There may be infinitely many parallel universes, each a book with its own parameters. We are only in the rare book, whose first page was gentle enough to let life bloom. Natural tuning. Maybe the constants must be as they are, because if they were different, the universe could not exist long enough to ask, why? Like water freezing at 0 degrees Celsius, the universe only exists at certain values. Blind spot of knowledge. Maybe these constants are not constants, but results of a deeper theory we have not yet found. As Newton thought gravity a force, Einstein found the truth that it is curvature of space. Perhaps one day, a child sleeping somewhere in the dark will grow to find the answer. The universe was not arranged to produce us, but that we exist in a universe that can produce us is a gentle fact, almost like poetry. You are the result of billions of years of tuning, the right gravitational constant, electrons of the right mass, water with the right structure, carbon of the right stability, a sun of the right brightness, an earth at the right distance. Just a small deviation, and you would not be here, lying still, listening to the narrator, and feeling each fact pass like wind over your skin. The universe tunes its constants to allow light, water, and life, but something stranger remains. Even when all conditions are right, the universe still contains unpredictable mysteries. We will continue to explore the questions science is touching, gently, like light, touching the surface of water. Go on, very slowly, because the more we go, the more the universe opens quieter things. The strangest thing about the universe is that even its shape, the thing that wraps everything we cannot fully see. Maybe the universe is infinite, maybe finite, maybe folded like the outside of a sphere, or maybe nothing like anything we can imagine. Each hypothesis has its own beauty. If the universe is infinite, you live in a space without edge, where galaxies extend forever, like a bottomless ocean. If the universe is finite, it may be like a giant bubble, but without an edge, because in curved geometry, going straight forever can bring you back to your starting point, like circumnavigating the Earth, but infinitely larger. If the universe is curved like a sphere, light does not travel straight. It bends with space. Travel far enough, and you return behind yourself. A gentle loop of reality. Current science measures that the universe is nearly flat, with a very small uncertainty. But flat here does not mean flat like a sheet of paper. It just means flat in how light moves. Like a vast plane, you stand there, you don't see curvature, but Earth is still a sphere. Flat space does not tell how large the universe is. It only says that the path of light looks like Euclidean geometry. Space may appear flat to you, but curved in depths we cannot yet see. Another hypothesis says the universe might be compact, meaning it is not infinite, but folded across many dimensions, like a circular tube in three-dimensional space, or a donut torus, or a twisted lattice, like silk fabric. In those shapes, light can return to itself, creating a repeating universe in a mirror, a faint duplicate of a galaxy appearing far away. If one day you look through a telescope and see the Milky Way very far away, that might be another version of where we live, but that light has traveled for billions of years. Maybe you are looking at your own home, but in the shape of ancient light. Multiverse. This idea is not mystical philosophy, but stems from quantum mechanics, string theory, and models of cosmic inflation. In those theories, our universe is just a bubble in an ocean of infinite other bubbles. Each universe may have different constants, different physical laws, more or fewer spatial dimensions, a different reality. Perhaps somewhere, another version of you is listening to this story in a universe similar, but never touching. If the eternal inflation model is correct, space keeps inflating on the large scale, and small regions that stop inflating form individual universes, like droplets condensing in fog. One droplet does not touch another, yet all coexist. Each universe could be infinite, finite, curved, flat, many-dimensional, or almost unimaginable. Maybe we are living on a tiny petal in the endless garden of space. If there are infinite universes, most will not permit life. Matter will dissipate, or gravity will be too strong, or there will be no atoms, or time will not exist as we understand it. Our universe is just one of the rare universes where life can reach the light. This is called the anthropic principle. We observe the universe tuned for life, because if it weren't, we would not be here to ask this question. We exist not because the universe needs us. We exist because we are in the place where life can arise in a sea of infinite other possibilities. Enter. If the constants are tuned so life could appear, then the multiverse tunes the possibilities that life could dream of. Some scientists compare the structure of the universe to a neural network. Supercluster filaments like synapses, void like gaps between cells, streams of dark matter like electrical signals. The universe might not only be where we live, but also a mirror of consciousness itself. We do not know whether the universe is infinite or finite. We do not know whether it is curved or flat. We do not know how many universes breathe with us. But there are mysteries that don't need size or shape. They are not in the picture of space, but in the strange things of reality itself. Now, come with me to where light has never touched, but human imagination has always aimed. The strangest thing of the universe is not in the gigantic, but in the smallest. If the world of galaxies is a grand symphony, then the quantum world is a whisper so small that only the most delicate experiments can hear it. At the quantum level, smaller than atoms, smaller than electrons, smaller than the mind, can picture, every rule of ordinary life dissolves. At that level, particle is no longer a particle. Wave is not merely wave. And reality is not as solid as we thought. This phenomenon is called quantum superposition. If you throw a pebble, it will fall to a single position. But if you throw an electron, it does not pick a position immediately. It is everywhere it could be, all states, all positions at once. It is a wave of possibility. It only chooses a position when you observe it. A particle is not truly anywhere until you look, as if the universe only completes itself when a consciousness listens. That sentence floats light as a leaf on a pond, an old mystery as the universe itself, and as new as the first time we heard it. If someday you touch a tiny particle, and another particle at the other end of the universe instantly knows what you did, you would think it magic. But it is physics. It is quantum entanglement. Two particles are linked, not by cords or forces, but by a shared state, like two candles burning from the same flame. No matter how far apart they are, a tiny change in one particle instantly appears in the other. Science once believed nothing travels faster than light, but perhaps information does not need to traverse space. Maybe, in a very deep place, two particles never separated. Albert Einstein called this phenomenon spooky action at a distance, but even he, one of history's greatest minds, could not explain it. The important thing is not how strange the tiny particle is, but the truth that everything, you, me, the planet, stars, galaxies, is made from those particles. Meaning, you also contain the possibility of existing in many states. You are woven from invisible connections that span space. You are both wave and particle in a single breath, meaning the deepest nature of us is also illogical, borderless, and as limitless as the universe itself. Perhaps you are not separate from the world as you once thought. You are part of a deep, light, continuous network where every particle remembers the other. After telling of quantum phenomena that surpass imagination, the narration turns slowly toward you, like a lamp swinging to illuminate the child sitting in the dark. If particles can be in two places, can consciousness be in two states? If two particles are entangled, can two people sense each other across thousands of miles? That vague question is asked not to explain, but to stir a gentle breeze blowing from science into the soul. The universe is vast, but sometimes the strangest things are in the smallest, in those invisible particles that constitute each cell, each thought, each dream of yours. And if those tiny mysteries have shaken logic, then the mysteries of life, consciousness, and memory make the universe even gentler. Now, let us leave the world of particles and go to a place closer where life itself still poses questions that science lacks the language to answer. The quantum world holds an even deeper secret, a secret that shakes the concept of reality itself. In everyday life, you look at a chair, and your looking does not change the chair. But in the quantum world, mere observation will change reality permanently. This is called the observer problem. The double-slit experiment is a famous example. If we do not observe an electron, it goes like a wave, present in many places. When we observe it, it decides to be a particle, choosing a single position. As if the electron says, "Oh, you are watching me? Then I will behave as you expect." We thought reality was objective, but it turns out it knows when we look. That mystery not only troubles physicists, it evokes a feeling that the universe is in a silent dialogue with consciousness. Some scientist once wrote, "Reality does not form until we participate." That thought is soft as a speck of dust in sunlight, fragile, irrational, and beautifully gentle. Does consciousness truly force the universe to choose a state? Or is observation merely a physical interaction, unrelated to spirit? Or do all possibilities exist, and we only see one branch among many branches of reality? Some physicists suggest the universe branches every time an observation occurs, forming countless parallel worlds, each world corresponding to a different possibility. We do not know, and perhaps we do not need to know, for it is the not knowing that makes the universe gentler. We have just seen that consciousness can affect the smallest things. But what about the largest? Nothing is larger than the force that wove galaxies, that governs planetary orbits, and keeps the Earth under your feet. That force is gravity. You think you understand gravity, the thing that pulls you to the ground, the thing that makes an apple fall on Newton's head. But the truth, gravity is one of the greatest mysteries of the universe. If you lift a pen off the table, you are using the force of your hand to overcome the pull of the entire Earth on that pen. You, a small creature, defeat the pull of a planet. That shows gravity is weak to the point of absurdity. The strong nuclear force that holds particles together is even stronger. So why alone is gravity so weak? No one knows. There are theories that gravity leaks into other spatial dimensions. Gravity is actually strong, but is diluted across many dimensions. Or gravity is not a force, but the curvature of space-time, according to Einstein. But all remain hypotheses. Maybe gravity is weak, because if it were stronger, the universe would collapse. Or perhaps it is weak, so we can exist. A gentle hint, tinged with Zen, as if the entire universe has been tuned for life to shine. Gravity is like the universe's embracing arms, not too strong to crush, not too weak to let us fly away. It holds the sun, keeps planets in orbit, holds the oceans under the sky, and keeps you standing amid the currents of life. An invisible embrace holds everything. Some scientists believe if gravity were a bit stronger, stars would burn too quickly. Life would not have time to form. If it were a little weaker, no galaxies would form, like a thin thread holding everything between abysses. There are big mysteries, like the shape of the universe. There are small mysteries, like quantum entanglement. And there are mysteries connecting everything from the very large to the very small, like gravity. But the mystery does not stop out there in the universe. It seeps into us, into memory, consciousness, emotion, and the things we think are most familiar. Oh, now, let me take you out of space and into a world more mysterious than the universe, your own mind. There are mysteries not only vague, but contradictory to the things we thought we knew. The heart of modern physics is built on two pillars: general relativity describing space-time, gravity, galaxies, the universe on large scales; quantum mechanics describing particles, waves, probability, and strange jumps at small scales. Both are true, both are accurate to terrifying degrees. Relativity helps us predict planetary orbits. GPS operation describes black holes. Quantum mechanics helps us create smartphones, lasers, computers, all modern devices. But there is a cold truth. Those two sets of laws cannot be unified. They cannot coexist in a single equation. When combined, equations explode into infinity. Numbers lose meaning. Nothing retains logic, as if the universe operates by two different rulebooks depending on whether you look near or far, large or small. The universe is like a book with two languages, and we have not found the dictionary page to translate them. Black holes are not just places where light is trapped. They are where the universe's two laws clash most fiercely. At the surface of a black hole, the event horizon, relativity says time slows down, nothing escapes. But quantum mechanics say particle can jump, can leak, can escape as radiation. Stephen Hawking discovered black holes can evaporate, an impossible thing. So where does the information go? Does everything that falls into a black hole disappear forever? Or is it preserved on the surface like a cosmic hologram? This is the information paradox. and to this day no one has explained it. Black holes are where reality no longer obeys what we know. At the center of a black hole is what is called a singularity, a point infinitely small, infinitely dense, where density and gravitational pull approach infinity, where time and space lose meaning. There, relativity collapses. Quantum mechanics also fails. It is where physics stops working. It is not just a point, but the final wall of knowledge. Stephen Hawking, who spent his life staring straight into black holes, found that black holes are not eternal darkness. They leak heat, they leak energy, they leak information, perhaps, and ultimately, they evaporate completely, leaving behind pure emptiness. But what is that emptiness? If information cannot be destroyed, where did everything that fell into a black hole go? No one knows. Current equations cannot say. Here the narrator draws you back to the very first moment, where the Big Bang is said to originate. But even the Big Bang is a question. Relativity says the universe began from a singular point, an infinite point like the center of a black hole. But quantum mechanics says that at extremely small scales, there is no such thing as a point. The universe cannot be compressed into a point. Space-time cannot contract to infinity. The two theories clash again. Maybe the universe did not explode from nothing. Maybe there was much else before, but we cannot yet see it. Space-time in relativity is a fabric that can bend, but in quantum mechanics, everything vibrates, even the vacuum. There are theories that space-time is not continuous, but woven from extremely tiny atoms, like threads in a fine cloth. There are theories that it is merely a shadow of a higher dimension. There are theories that it is the surface of a multi-dimensional bubble. But all are hints. The universe has not given us the answer. Space-time may not be the stage for the universe. It may be a character in the story. Black holes cannot be explained. Absurd singularities. Hawking evaporation contradictions. Big Bang that cannot be described. Space-time not understood. Relativity and quantum cannot be unified. We begin to feel that the universe is so vast that science is only reading the first few pages of the book. The rest of the pages remain blank, and it does not frighten us. It only makes us gentler, because even the unknown has its own beauty. There are mysteries so large they swallow all theories. There are mysteries so small they shake the concept of reality. But there is another kind of mystery, close, subtle, and quietly shaping all life. These are the things science cannot explain. Not out in the universe, but within people themselves. Now, let me lead you into the mysteries of life. Memory, emotion, instinct, and awareness. Things even science has not yet found words for. And when we look up at the sky, we are not only looking at stars, we are looking at questions the universe itself has not answered. First, the narrator invites you to imagine you are floating above a spiral galaxy, not a 2D textbook image, but a gigantic vortex of light, slowly rotating like an endless dance. Light bands roll into arcs, arms twist long as if stretching, star clusters scatter like glass fragments on the night sea. A structure too beautiful, too ordered, too smooth to be mere chance. But the question is, why is it so perfect? Theoretically, when a galaxy rotates, the inner parts should rotate faster than the outer parts like a bicycle wheel. If so, the spiral arms should be stretched, twisted, and distorted over time. But they are not. Despite spinning for billions of years, the arms still sweep through space with pristine beauty, as if the universe preserves their order with an invisible hand. Scientists call this structure a density wave, a kind of density wave like traffic clusters on a highway creating fixed jams. But why does that wave persist for billions of years? Why does the shape remain so even and smooth? Why do most large galaxies choose that exact shape rather than chaos? No one knows. There are structures in the universe so beautiful that we can only look at them because explaining them would strip away their poetry. From that gentle spiral, we are led to a mystery that is its complete opposite. Fast, violent, rough, powerful, like the cough of the universe itself. Fast radio bursts. Explosions of radio waves that last only a few thousandths of a second, yet shine brighter than an entire galaxy. They flare, then vanish, leaving no trace, not repeating, like a blink of space. When scientists first discovered them, they thought it was a glitch. But what kind of glitch shines brighter than a collection of hundreds of billions of stars? FRBs appear scattered throughout the universe, so far away that their light takes billions of years to reach Earth. What is more terrifying, they do not come from anything we understand. Not supernovae, not neutron star collisions, not black holes, not pulsars. Every hypothesis has been eliminated. Some FRBs come from ancient galaxies. Some come from empty regions outside the galactic disk. Some repeat periodically, but no known energy source matches such frequency. Sometimes, the universe says one sentence and then stays silent forever. FRBs are like whispers from dimensions we have never touched, or like strange dreams born and gone before we understand them. Following FRBs, the narrator brings us to another mystery. Thin as breath, there are dim galaxies filled with dust and dark matter, but no stars, not a single light, not a single hot spot, not a single explosion. They drift like wandering souls, like houses built but never inhabited. The biggest question, why do they not form stars? To form stars, hydrogen gas must collapse. But these galaxies have gas. They just don't collapse for reasons unknown, as if someone switched off the foundation of light formation itself. One galaxy among them, DF2, stunned the astronomical community. No bright stars, no dark matter, no adherence to common models. It is like a mistake in the cosmic book, but it is completely real. Alongside starless galaxies, there are ghost galaxies, ultra-diffuse galaxies. They are as large as the Milky Way, but dozens of times lighter, sparse, faint, fragile, like an overexposed sketch in graphite. They exist, but no one understands why they do not collapse. When their gravitational pull is so weak, the answer may lie in dark matter, or perhaps they are remnants of colossal primordial collisions. But all are only theories. Galaxies also have old age, and sometimes that old age appears as a fading shadow. To understand celestial bodies, we must understand their context, but the universe itself is a mystery. There are three possibilities: a flat universe, infinite, not curved; a positively curved universe, like the surface of a sphere, where traveling straight brings you back; a negatively curved universe, like a saddle, expanding infinitely fast. Current data leans toward the universe being almost perfectly flat, but almost is never enough in cosmology. A difference of 1/1,000,000th would completely change the structure, number of galaxies, and expansion rate. If the universe is not flat, and we are living on the curved surface of a larger dimension, then what surrounds it? A question soft like water, but deep like a black abyss. The Milky Way, Andromeda, billions of galaxies in the Virgo cluster. They are not randomly distributed. They gather into long threads like networks, voids vast as empty bubbles, giant nodes where hundreds of galaxies connect. The universe looks like the neural network of a brain. Perhaps the universe is a living being, and this structure is its fingerprint. Science calls this the large-scale structure of the universe. But why is matter arranged this way? Gravity? Dark matter? Primordial ripples in the CMB? No definitive answer. The universe does not only ask questions about the vastness, but also about tiny ripples, dust grains that dance, vibrations smaller than imagination, phenomena so small we can feel them but cannot measure. But not only galaxies hold big secrets. There are smaller, lonelier objects, so precise they humble science. Pulsars are the cores left after supernova explosions. They are smaller than a city, but heavier than the Sunday. Imagine this: an object only 20 kilometers wide, yet 1.42 times the mass of the Sunday, so dense that a teaspoon of pulsar matter weighs as much as the entire Himalayas. But the mystery is not their density or speed, but their terrifying precision. Pulsars emit beams of radiation from their poles, and each time a beam sweeps over Earth, we receive a pulse. Like the ticking of a clock. But this clock, never late, never early, never off by even a fraction of a billionth of a second, spinning hundreds of times per second, unchanged over millions of years. Some pulsars are more precise than atomic clocks, the most accurate devices humans have ever made. This shocked scientists. How can a star, spinning hundreds of times a second, be more precise than our finest machinery? Some hypotheses: its core may be superfluid. Its gravity freezes motion. Its magnetic field is perfectly stable. But all explain only a small part. The narrator whispers, voice drifting through darkness. If anything in the universe knows time perfectly, it is a pulsar. If pulsars are clocks, magnetars are silent storms. They are rare, extremely rare. Among hundreds of billions of stars, only a few dozen magnetars exist, but they are so powerful that a magnetar 1,000 light-years away could erase all data on Earth with its magnetic field alone. A magnetar's magnetic field is 1,000 trillion times stronger than Earth's, and sometimes they twitch. Just a tiny crustal movement, less than a centimeter, can release energy millions of trillions of times a nuclear bomb. These flare-ups are called giant flares. They are so brief, we sometimes detect them only after they happen. And to this day, no one knows what makes magnetars angry. Is it magnetic collapse, cracking field lines, or something happening in the exotic matter within their cores? Every theory stops at a wall of mystery. There are stars that do not speak. They only breathe with explosions we cannot understand. Earlier, we met FRB's radio flashes lasting 1 millisecond. For years, no one knew their source. But in 2020, a turning point. An FRB was detected coming from a magnetar within the Milky Way. This raises the question: are magnetars the source of FRBs? Possibly, but only partly. Because some FRBs are too powerful for magnetars to produce. Some come from places with no magnetic sources. Some repeat which magnetar theory cannot explain. As if FRBs come in many types, many origins, many stories. After pulsars and magnetars, the narrator turns to a deeper mystery. Cosmic rays, ultra-energetic particles. Every second, millions of high-energy particles pierce your body without you knowing. But we still don't understand. Where do they come from? Supernovae, neutron star collisions, magnetars, regions near supermassive black holes. But some cosmic rays have energy so high that a single proton carries as much energy as a baseball thrown by a human hand. This is absurd. A particle smaller than an atom holding more energy than a moving object we can see. No model can explain it. The particle is called the "oh my god" particle, the scientists' real reaction. After drifting through cosmic rays, pulsars, and magnetars, the narrator softens their voice, as if soothing the mind after so many strange things. Perhaps we will never understand. Perhaps these phenomena are not meant to be understood, but to be felt. Pulsars perfectigs, magnetars thunder drums, FRBs flashes, then silence. Cosmic rays invisible arrows, all like instruments in the symphony of a universe trying to tell its story in a language beyond human comprehension. But the mysteries are not only in the strongest stars, but also in the familiar things. In Earth, in biology, in consciousness, places science thinks it knows, but has only brushed the surface. If you are ready, let us move to mysteries closer, gentler, yet equally deep. M. The giant voids of the universe. The universe we live in is not randomly arranged. From very far away, far enough that every galaxy looks like dust, you'd see the universe arranged like a web of filaments, interwoven veins of light, walls, threads, nodes, and vast emptiness called cosmic voids. These voids are so enormous, it's hard to grasp. Some are hundreds of millions of light years wide. Some contain 100 times fewer galaxies than normal. Some are as large as 5,000 Milky Ways placed side by side. If the universe is a neural network, the voids are its long breaths between shining wires. They are not just empty. They are regions where matter refuses to gather, where gravity barely whispers, where light passes without bending. Science has many theories, none certain. Hypothesis 1. Uneven primordial matter distribution. In the young universe, matter was not uniform. Slightly denser areas became galaxies. Slightly emptier areas became voids. But the strange part, some voids are too large to be random, too round, too clear, as if someone blew a cosmic breath, hollowing space. Hypothesis 2. Dark energy pushing matter out. Some scientists believe dark energy is stronger inside voids, creating pressure that pushes matter outward, making them emptier. Hypothesis 3. They may be traces of another universe. Some bold theories say a gigantic void might be where our universe collided with another, leaving a cold spot in the CMB still unexplained. Perhaps voids are not the absence of something, but the imprint of an encounter. In that darkness, the universe rests. It is where light relaxes, where time slows, where gravity becomes a whisper. Voids are not emptiness. They are the universe's breath, balancing fullness and absence. They highlight galaxy-rich regions, the way silence highlights music. After drifting through voids, the narrator gently shifts, smooth as sunlight turning to dusk. And when speaking of emptiness, we cannot forget the greatest emptiness ever, the emptiness of time. Not empty space, but an empty era, the time when the universe had no light, a real period called Cosmic Dark Ages. Imagine the universe born after the Big Bang, a space expanding, matter cooling, forming hydrogen and helium, but no stars, no galaxies, nor light shining, everything drowned in absolute darkness, lasting 100 million years, a night 1,000,000 times longer than human existence. If the universe's history were one long night, this was the moment you lay down and the world fell silent. Then, in that darkness, a miracle. The first clouds collapsed, cooled, and, under crushing gravity, began to glow. These were the first stars, population 3 stars. They were 100, 300 times larger than the Sun, 1,000,000 times brighter, living only a few million years before exploding, creating the first elements: carbon, oxygen, iron. In other words, they are the reason your body exists. Without them, there would be only hydrogen and helium, no carbon for cells, no oxygen to breathe, no iron to tint your blood red. You carry the fire of the first stars within you. Even with telescopes like James Webb, we have never seen a population 3 star. Too far, too bright, too short-lived. Gone before their light reached us, like a whisper we can never hear. Thus, the birth of light is still a mystery. We know it happened. We see its traces, but we have never witnessed it. The most important moment of the universe still escapes human eyes. After voids and eternal night, the narrator ends with a line soft as a petal on water. The universe is not made only of light, but also of silence. And in that silence, the greatest wonders are born. If you are ready, we move to closer mysteries. Strange planets, failed stars, worlds science can only call not yet understood. If the first stars had barely formed, why were there supermassive black holes before light had even spread? Looking into distant space, where light takes tens of billions of years to reach us, we find something strange. Supermassive black holes, billions of times heavier than the Sun, existed just 200, 400 million years after the Big Bang. That time is barely enough for a star to live, explode, and collapse, let alone grow into such giants. The question cracks our understanding. How could they grow so big, so fast? Hypothesis 1. The first gigantic stars collapsed directly into black holes. Perhaps the newborn universe was so different from today, hotter, denser, matter clumping faster. Under those conditions, some gas clouds did not form stars as usual, but collapsed directly into black holes, weighing up to 100,000 times the Sunday. Those black hole seeds could grow as quickly as trees in the rainy season. But the problem is, they would have to grow so fast that science is bewildered. Hypothesis 2. Early black holes could eat matter faster than predicted. According to classical physics, a black hole can only swallow matter up to a certain rate, called the Eddington limit. But ancient black holes did not care about that limit. They swallowed everything that came near, as if the universe had tasked them to grow huge early to prepare the birth of the first galaxies. As the narrator whispers, maybe in the infancy of the cosmos, the universe nursed its first children in a different way. Hypothesis 3. Black holes formed from the collapse of dark matter regions. This is a bold idea, and also one of the most beautiful. Dark matter, the invisible substance that makes up most of the universe's mass, might have itself collapsed into dense cores, condensing and producing black holes from the very first seconds after the Big Bang. If true, then ancient black holes are not the product of any star, but direct offspring of the Big Bang. Dark, silent seeds, waiting to be seen. Hypothesis 4. The universe passed through eras we do not yet know. Some physicists suggest that time in the early universe may have flowed differently than now. There could have been phases during which the growth of matter, energy, and black holes happened in a single breath. Hard to observe from our vantage point today, as if the universe lived its childhood in a dream of speed, then awoke, leaving traces we are still decoding. When we look into distant space, we are also looking back in time. A black hole 13 billion light-years away is an image from 13 billion years ago. Perhaps time ran faster in the early cosmos, or space-time then had properties we no longer see, or a possibility as beautiful as a musical motif. The early universe allowed everything to happen under laws now asleep. Ancient black holes remind us the universe once had powers we no longer possess. Although we do not know how they formed, science believes these supermassive black holes played crucial roles. They pulled matter toward them. They produced swirling jets of gas, heated to millions of degrees. They helped galaxies gather around them. Perhaps they gave birth to light by enabling the first stars to form. In other words, some of the earliest galaxies were born around ancient black holes, not the other way around. They are not monsters. They are the universe's embryonic centers. Ancient black holes lie so far away that their light traveled through billions of years, thousands of galaxies, thousands of voids, expanding patches of space, and millions of cosmic changes. We see a version that has cooled, transformed, warped by time. Those black holes might no longer exist, or may now be 100 times larger, or may have merged into structures we cannot yet imagine. We are seeing the ancient souls of the universe, each of which has lived far more lives than we thought. And if ancient black holes are mysteries of the dawn, what about the oddities inside familiar galaxies, stars, and worlds around us? Mysteries that sit inside the universe we think we know. Let us continue to the next mysteries. Things that, though seen, humanity still cannot fully comprehend. Even our home contains things science cannot yet explain. And so, light as a step on damp sand, we enter the realm of oddities within the most familiar cosmos. At first, everyone believed Saturn's rings had existed since the solar system's birth about 4.5 billion years ago. They were thought to be an ancient legacy, an ice and rock masterpiece that had accompanied the gas giant since the dawn of time. But quietly, science realized something incredible. Saturn's rings may be only tens of millions of years old, so young that, when dinosaurs walked the Earth, those rings might not have existed. When the first rains fell on our planet, Saturn could still have been naked. Perhaps the rings appeared recently, like an unexpected ornament of the solar system. This makes the listener realize even the solar system's most beautiful icons are not eternal. Their origins are unknown, their ends uncertain, and in a voice as soft as a drifting cloud, the narrator gently asks, if rings can appear and vanish like a breath, what else about Saturn do we not know? As the tale quiets, the narrator moves to another mystery, so strange it seems as if science is teasing us. Among all the planets, only one chose to lie tilted at 98 degrees, rolling around the sun like a ball on the floor. Uranus does not spin upright, it spins nearly on its side. Scientists propose many hypotheses. Maybe it was struck by a giant planet, or a large moon slowly pulled it over, or perhaps it was born that way. But the truth is, we do not actually know what made a planet defy the rules and tilt as if drunkenly sleeping in space. There are secrets not at the universe's edge, but on the seventh planet only 2.7 billion kilometers away. A world turning slowly as in a dream, dragging its seasons, climate, and winds into a wholly different rhythm. Uranus tilted, the narrator exhales and invites us to a stranger place, still Venus, Earth's sister planet, that chose a life completely unlike ours. Venus's story is not only scorching and toxic. The strangest thing is, Venus rotates the opposite way from most planets. While Earth, Mars, Jupiter, Saturn rotate west to east, Venus spins east to west, as if rejecting every rule. Not only that, a day on Venus is longer than a year. It spins so slowly it is almost motionless, and its temperature is hot enough to melt lead. Why would a sister planet become such a strangely warped twin? No one knows. No model fully explains it. No experiment has enough data. Venus is like a soul swimming upstream, not because it is wrong, but because its life story is different. And when the story touches the deepest parts of the solar system, where sunlight is no longer warm enough to heat a hand, the narrator leads us to the world of storms we cannot fathom. Neptune. The strangest thing? Neptune has gigantic, fiercely spinning storms, even though it receives almost no energy from the sunday. In theory, the farther a planet sits from the sun, the colder, quieter, less turbulent it should be. But Neptune has the strongest winds in the solar system, up to 2,400 kilometers per hour, black storm vortices that open and close, vanishing like magic, storm bands that blow in reverse across the planet itself. How can an ice world hide such a chaotic heart? The reason sadly remains beyond our grasp. Some believe it has an internal heat source. Some think there are aerodynamic laws we have yet to discover. Others admit maybe Neptune is a countercurrent mystery, like a concert in the cold, without logic, only its own rhythm. Even the closest worlds are not truly understood. Saturn's rings are only a few million years old. Uranus tilts as if asleep. Venus spins backward like a mist beat. Neptune hides a storm in endless dark. These things are not exceptions. They are signs that science knows far less than we imagine, even about our own home. The solar system is not a perfect machine, but a piece of music with odd notes, offbeat measures, and passages drowned in silence. If even the nearest planets hold such mysteries, what then when we look at Earth itself, the place we live, breathe, dream, love, and heal? Could this planet also hide doors science has not yet opened? Let us go on, for the universe is strange not only far away, but right beneath your feet. Europa is not the place you imagine when you think of life. It is cold, very cold. Its surface is completely covered in ice, white to the point that the rare sunlight that touches it almost entirely reflects. No hills, no forests, nor rivers. Europa is stillness. But if we look more closely, very closely, we see cracks like long veins of time, sheets of ice shifted like a frozen symphony. And science whispers, beneath there, something moves. Because Jupiter, the giant of the solar system, tugs Europa with tidal forces so strong that this moon is stretched, then relaxed. Each day, each hour, each second, like a heart beating, expanding, and contracting. That tugging creates heat, and heat melts ice, not on the surface, but tens to hundreds of kilometers below. And so, beneath that silent white shell, an ocean larger than all Earth's oceans combined exists, flows, whispers to the dark. If life needs water, heat, and chemistry, then Europa has all three. We do not know what drifts under that ice. Microbes, hydrothermal mountain ranges, or life forms beyond the imagination of humankind. Europa is a question the universe asks us, and no one has the answer yet. If Europa is a quiet mystery, Enceladus is a bold one. On Enceladus, life, if present, does not hide in absolute silence. It breathes, it vents, it shoots giant plumes of water vapor into space like a message. Look at me. Enceladus's surface is a mirror of ice colder than Earth's deepest nights. But at its south pole, blue fractures, called tiger stripes, glow with heat. From those fissures, water columns hundreds of kilometers high shoot into the sky, like hot springs singing in the darkness of space. The Cassini spacecraft flew through those plumes. It tasted them, literally, and inside, it found liquid water, sea salts, organic molecules, hydrogen, an energy source for microbial life. All of that on a moon the size of California. Enceladus is small, but has an ocean tens of kilometers deep, and at the ocean floor, people believe hydrothermal vents exist, like the places where life first formed on Earth. Enceladus does not just ask, "Is there life beyond Earth?" It whispers, "If there is, I might be the first place you find it." Life, if it exists on Europa or Enceladus, will not resemble anything we know. No sun, no light, no green, but they possess a different beauty. The beauty of patience, the beauty of oceans waiting for billions of years in darkness. The beauty of worlds not flashy, but holding astonishing potential. In this vast universe, perhaps life does not seek light to be born. Maybe it seeks warmth, seeks motion, seeks places where water is retained, even if only a drop. And that thought that in those little moons, in complete darkness, something might breathe, live, move, brings a strangely warm feeling, as if we are not alone in the cosmos, as if, though we have not seen anyone out there, life persists, gentle, deep, patient, waiting in places we least expect. And then, when we leave those breathing subsurface oceans, we drift toward the farthest boundary of the solar system, where ices do not only store water, but also the memory of the primordial age, places where time almost stands still. After seeing wonders out there, let us return to the planet we stand on. Among all Earth's mysteries, perhaps none is stranger than the seemingly simplest question: where did the water come from? We drink water every day. Water runs through mountain veins, through the breath of clouds, through oceans beating on shores like a great heart. Water makes up 70% of our bodies, and over 99% of Earth life depends on it. But the origin of water, the most important thing for all life, still has no definitive answer. The narrator continues as softly as waves. We live our lives surrounded by water, yet we do not know exactly how water came to be here. That is also a beauty, the beauty of the familiar that remains mysterious. Some scientists think water existed in minerals when Earth formed, tiny crystals, trapped water molecules, hidden in molten rock of the early world. Others believe water was delivered from outside by icy comets and mineral-rich meteorites. As if young Earth was watered by the cosmos' ancient rains, bringing the first streams. There are theories saying both are true. Some of our water was born in Earth's interior, the rest arrived from distant skies. A planet gifted with life, by both what is inside it and what comes from beyond. The strange thing is, despite observing the vast universe, we have found nowhere quite like Earth. It seems almost irrational. The irrational beauty is like a poem. Earth sits at just the right distance for liquid water, has the right atmosphere for breathing, has a magnetic field for protection, has the moon to stabilize its tilt, has continents, oceans, the carbon cycle, and hundreds of finely tuned conditions. But sometimes, that beauty lies not in perfection, but in the small mysteries we often forget. Because Earth with all its familiarity, still keeps secrets. One question scientists still ask: why does Earth have so much water? Other planets in the solar system are mostly dry. Or, if water exists, it is a little ice in eternal darkness. But Earth has oceans tens of kilometers deep, enough to cover an entire other world's surface. Why were we so favored? Perhaps geology, perhaps random impacts, perhaps an unrepeatable coincidence in 14 billion years of the universe. Or perhaps one day, science will understand. But today, in the space of sleep, we only need to recognize that Earth is a miracle, and miracles sometimes do not require explanation. If you listen closely, the rocks of Earth can tell stories, and sometimes they tell of the sea. Minerals in the world's highest mountain ranges bear traces of organisms once living on ancient seabeds. Tiny fossils found on Everest's summit, a reminder that the highest places were once ocean floors. This proves Earth has never been still. Continents drift, ocean reshape, and time continually redraws the planetary picture. But through all that change, water remains the central character, a quiet current linking past, present, future. Humankind has asked this question for thousands of years. There is no conclusive answer. Each hypothesis is a story. Each story, a piece of the larger puzzle. And perhaps the most important thing is not that we have not decoded it, but that we are still searching. Humans are born of water. We grow in water. Our first memory in the womb is a small ocean. Perhaps that is why the question of water reaches something deep inside the soul. And in that moment, the listener feels something strange. Science can also be gentle as a touch. A mystery can also heal. But water is only one of Earth's secrets. This planet holds hundreds more riddles. Riddles in rock, in sky, in our own bodies. And now, let me lead you to the second mystery. A mystery beneath your feet, in Earth's crust, in the breath of continents and oceans. But water is only the beginning of something stranger, a planet that moves beneath its own feet. And the first question rings softly. Why does only Earth have plate tectonics? There is no planet like Earth in the solar system. Venus lies still under acid clouds. Mars sleeps, cold and cracked. Mercury is silent, like a hot bead. Only Earth knows how to shift. Earth's crust is not a single shell, but a spine of dozens of large and small plates, drifting on a soft magma layer, like stone ships. Mountains rise, oceans open, continents separate, join, and separate again. The whole planet breathes, rhythmic and endless. To date, science understands only part. Does water make rocks softer? Does the liquid iron core create strong convection? Or was Earth born active from the start? No one knows for sure, but perhaps that capacity to move created life. A static planet would struggle to harbor life. A moving planet builds mountains, seas, climates, allowing evolution to change, adapt, and flourish. Perhaps life needs not only water, but a planet that moves from within. Why does Earth's magnetic field reverse periodically? Sometimes north becomes south, south becomes north. Polarity reversals have occurred hundreds of times in history, like flips of an invisible heart. Earth's core is a terrifyingly hot iron sphere, hotter than the sun's surface, yet solid because of immense pressure. Around it, a layer of liquid iron churns, creating a natural dynamo, a magnetic field protecting life from solar radiation. But no one knows precisely why those iron flows suddenly reverse direction, like water swirling down a drain changing course. It may be due to turbulent convection. It may be due to plate motion. It may be simply the planet's habit. The strange thing is, when magnetic poles flip, life continues. No catastrophe, no annihilation. As if Earth simply turns a little, shifts its sleep direction, then continues, guarding everything on its surface. We do not fully understand the magnetic mechanism, but we feel its tenderness. A magnetic blanket wrapped around the planet, keeping all small lives quietly asleep through the night. There are times when Earth becomes a snowball. Oceans freeze, vegetation sleeps. The causes of ice ages remain a riddle. Maybe slight orbital shifts, maybe changes in axial tilt, maybe plate tectonic cycles bring continents toward the poles, or perhaps all of the above, cooperating like a climatic chord. Earth occasionally inhales, and the whole planet grows cold. Then it exhales, oceans thaw, and life blooms. Science calls this the Milankovitch cycle, the long breath of the planet, a breath lasting hundreds of thousands of years. There are nights when, during an earthquake, people see strange lights flash in the sky. Purple light, white light, blue like cold electricity. These are called earthquake lights, a mystery with no solution. Some hypothesize rock compression releases charge. Some say gas ionization. Some propose plasma rising from the Earth's interior. But no one has observed it in a lab. No one has reproduced it. A mysterious glow, visible for only a few seconds, when the Earth silently cracks, as if the planet says something, in the language of light escaping from stone. One of Earth's most incredible phenomena, ball lightning, glowing spheres floating in the wind, passing through glass, circling for a few seconds, then vanishing, so rare that most scientists have never seen them directly. But thousands of witnesses have recorded similar accounts. That makes the phenomenon full of legend, yet real. No one knows what they are. Plasma, glowing silicon, charges trapped in the air, or simply something beyond current physics. When Earth wants to make magic, it does not ask science for permission. Oh, there are volcanic eruptions that change global climate with a single blast. Toba, Yellowstone, Talpo. But the frequency of such eruptions follows no rule. Some volcanoes sleep millions of years, then suddenly awaken. Some erupt softly like a breath. Some explode violently like a final, long exhale. Why? No one knows exactly. Water? Pressure? Magma composition? Subsurface structure? Or simply that Earth has moments like us? No one knows. Some structures in the universe are so beautiful that we can only behold them, for explaining them would strip away their poetry. Emotions accumulate for a long time, then erupt all at once. There have been at least 5 major mass extinctions. Dinosaurs were only one of them. There have been times when life vanished by 90%. What caused it? Asteroids? Supervolcanic eruptions? Sudden climate change? Ocean anoxia? Plate tectonic upheaval? Or all of the above at once? No one is certain. Yet each extinction was also the beginning of a new chapter of life. Earth does not annihilate life. It redraws the picture to paint something new. Earth is full of unanswered questions, but that very imperfection makes it the only place we call home. Home. And now, having touched rock, water, fire, and sky, let me lead you to Earth's greatest mystery, the mystery of the origin of life. We are listening to life's first whisper, echoed from eras without light. After the planetary questions, water, plate tectonics, ice ages, the strange lights of earthquakes, the narrator slows. as if the whole tale descends from the atmosphere down into the deep of an even greater mystery, our own origin. And finally, we return to where every story begins. Not in a volcano, not in ice, but in the largest question science still cannot answer. Where did life begin? On the primeval Earth, the sky was red, seas boiled, continents newly formed. No trees, no animals, no eyes to witness. Only the silence before the first breath of life appeared. Two major hypotheses stand opposite each other. Life began at the seafloor, where hydrothermal vents spew minerals hotter than 300 degrees Celsius. There, molecules could self-organize, self-replicate, drawing energy from the planet's interior. Or life sprang up on land, in mineral-rich shallow pools, alternately dried and re-wetted by the sun, countless cycles, until a reaction different enough occurred. Both are plausible, both are beautiful, both lead to the same miraculous moment. A molecule that can store information, a droplet of solution that can copy itself, a chemical reaction that becomes life. But where did it actually happen? In the darkness of the deep sea, or beneath a young Earth's sunset? Science has no final answer, and that ambiguity makes our origin feel like a poem. Everything begins with chemistry. Atoms of carbon, hydrogen, oxygen, nitrogen, moving, colliding, linking into long chains. But why did some chains learn to copy themselves, to bias reaction pathways, to follow an evolutionary route, rather than millions of other possibilities? No one knows. Some believe life spontaneously arises from chaos. Some think it is an inevitable outcome of physics. Some see it as an astronomically lucky accident. But in the narrator's gentle telling, every hypothesis falls like fragments of memory. Life did not appear by magic. It appeared because the universe always seeks to become more complex and more beautiful. One of the greatest mysteries. How did single molecules assemble into cells? A cell, even the simplest, is a miniature universe. A membrane, energy, information, inside and outside, a purpose, to live and to duplicate. No one has found a halfway cell, something incomplete but forming, as if life leaped from molecule to cell. Suddenly, hypotheses try to explain. Maybe the first cell was a chemical-filled droplet. Maybe mineral bubbles around a hydrothermal vent. Maybe spontaneous oil membranes in the ancient sea. But all are conjecture. In the darkness of Earth's history, no trace remains. Perhaps life was not created, but recognized that it already existed. Wherever life first arose, deep sea, desert, jungle, eternal ice, all life uses DNA or RNA. Why? There are billions of other molecular ways to store information, some even simpler than DNA. But life chose DNA and has remained faithful to that choice for 4 billion years. No one knows why. Maybe it was the first random choice. Maybe it is the most stable structure. Maybe this universe favors DNA. Or maybe it's simply what we observe because other systems have vanished. DNA is like an ancient tongue, originating in the primeval times, passed from the first cell to bacteria, fish, trees, elephants, and finally, to us. In every cell of yours is the voice of an ancestor that was never present, yet whispers through billions of years. Science still isn't sure. Are viruses alive? They don't live autonomously. They don't feed themselves. They don't replicate without a host. Yet they evolve, they adapt, they attack, they sleep for thousands of years. So where do they come from? Three hypotheses stand like three forks in the dark. Viruses were once full organisms and then degenerated. Viruses are stray pieces of cellular DNA. Viruses predate cells' proto-life. Each hypothesis is partly true and partly false. Viruses are that blurred boundary between alive and not alive, between order and chaos, between memory and oblivion, a beautiful ambiguity. In the primordial soup, there were countless molecules, millions, billions, trillions. They moved, collided, combined, separated. But why did only a few of them form self-sustaining systems, self-replicating, and follow an evolutionary path? Luck? Mathematics? A law of nature? Or the universe's choice for things capable of creating beauty? There are so many molecules, but only some become life, and only one lineage among them became you. That moment lit a warm spark in the deepest part of the listener's mind. Maybe life is inevitable. Maybe it is a miracle. Maybe it is what the universe always wants to repeat wherever conditions allow. But whatever the answer, we stand within an extraordinary fact. Life chose its path, and we are a small note in that symphony. So, will life continue forever? Or is it a fleeting moment in endless time? And the journey prepares to move into the next section. The mysteries of evolution, of consciousness, of intelligence, of life that looks back upon itself. In the deepest darkness, is anyone whispering with us? After guiding the audience through the hazy doorway of life's origin, where blind molecules suddenly copied themselves, created and breathed the story, pauses for a beat. From the ocean floor to DNA molecules, from trembling first chemical reactions to the formation of cells, the audience has touched the fragile yet wondrous foundation of every organism on Earth. But as with all scientific journeys and all human dreams when we understand a part of life, the next question naturally rises like a soft wind. Are we alone? Instead, the narrator's voice settles, deep as the sea where life began, light as ashes drifting among stars. The universe is unimaginably vast. More than 2 trillion galaxies. Each galaxy, cant, pedwar cant, billion stars. Each star possibly hosting many planets. The number is so large that, for a moment, the listener may feel as small as a speck of dust drifting in sunlight. But the narrator reassures in velvet tones. Small does not mean alone. In science, there is a simple principle called the principle of mediocrity. The idea that we are not special. If life arose on Earth, it probably has arisen, is arising, or will arise somewhere else. But why have we not seen them? Not heard their signals? Not met another life? Perhaps they are too far. Perhaps they are so different our eyes and ears cannot recognize them. Or perhaps, as the narrator whispers, in this universe, silence is also a form of communication. We are used to imagining life through carbon, water, oxygen, but that is only one recipe among infinite possibilities the universe might try. Maybe somewhere life is silicon-based, bodies like living glass, transparent, cold, durable. Maybe water is replaced by liquid ammonia, flowing under the dim purple light of a red dwarf. Maybe a creature is not cellular, but a stable electromagnetic cloud, an entity that thinks inside a dense, gaseous envelope. Maybe life does not need organic molecules, but persistent oscillations of magnetic fields, or a self-replicating geometric structure in crystal sand. Perhaps, in distant places, life is like a song, existing only as waves, formless, bloodless, but with memory and continuity. If life can arise from rock and water on Earth, who says it cannot be forged from ice? from gas, from light, or even from darkness? These questions do not frighten. They open a larger sky for the listener's imagination, as if the universe itself encourages. Think broader, dream more. When speaking of life, we do not only ask, is anyone out there? But also, what conditions allow life to find shelter? Science calls that region the habitable zone, the Goldilocks zone. Not too hot, not too cold, where water can be liquid. But habitability is not only temperature, it is an intricate music. A planet must have enough mass to hold an atmosphere, a magnetic field to shield against stellar storms, organic material, energy, a day-night cycle, or variation to trigger chemistry, and long-term stability over billions of years. And among those countless conditions, there are millions of planets classed as potentially habitable. Hubble, Kepler, and TESS have found there may be 40 billion planets in the Milky Way within Goldilocks zones, a number large enough to bring a thin smile to the listener's face. Perhaps we are not alone. It's just that the universe is so vast and life so patient. Perhaps somewhere, someone also looks up at the sky and asks the very same question. After questions about extraterrestrial life, the narrative smoothly shifts into a gentle emotion, the connection between human loneliness and the universe's vastness. Earth may be just a speck of dust, but a speck that knows love, asks question, yearns for an echo from elsewhere. Life beyond Earth is not only a scientific question, it is a question of the heart. Is there someone dreaming like us? Someone who knows sorrow, joy, love, and longing? Someone who also looks up, hoping to see a light not belonging to their sky. But before searching for extraterrestrial life, we must understand what makes life on Earth sacred. What causes consciousness to awaken in this body of bone and flesh? Among all the mysteries of the universe, the human brain is the most mysterious. As the journey from extraterrestrial life gently closes, the narrator turns the listener back to the origin point ourselves. From frozen planets to distant galactic bands, from silent signals drifting through space, the story now bends toward the deepest place, the inner universe of human beings. Perhaps the greatest mystery is not out there, but inside the small head you rest upon the pillow. And a new journey begins soft, slow, quiet as breath. What turns a 4-kilogram lump of soft tissue into something that can love, remember, dream, suffer, create, and hope? Science still does not know. Some say consciousness is a flame born from the perfect arrangement of neurons. Some think it is a wave, a subtle oscillation of matter. Some hypothesize consciousness is a primitive property of the universe, like time and space, always present. Perhaps you do not merely live in the universe. Perhaps you are the place where the universe awakens. Consciousness remains an unanswered wonder. Dreams are the thin border between the real and the possible. We dream in deep sleep when the brain tidies and rearranges memories. But why do dreams have emotion? Why can we run, fly, speak with the dead? No one knows. Some scientists believe dreams are rehearsal for survival. Others that dreams are the mind's way of processing emotion. Some think dreams are nothing mere neural noise. When you dream, your inner universe tells your own story in a language only you understand. A waiting minute can feel like an hour. An hour of joy can pass in a few breaths. In the brain, time is not a clock. It is emotion. It is rhythm. It is novelty, attention, fear, or calm. When we are afraid, the brain accelerates. When we are joyful, the brain melts. When we are contemplative, time can compress to a point. Time does not live in the outside universe. It lives inside you. Memory is not stored in a drawer, not a file, not a film. Memory is a network of millions of neural connections, reshaping each time you recall it. That means each time you remember, the memory changes. That is why we can argue about what happened. Everyone keeps a different version. Memory is a living song. Each playback is performed anew, with the feelings of the present moment. Why do we love? Why do we grieve? Why does one person look into our eyes and we feel understood? Emotion is not only in the mind, it is chemistry, plus memory, plus survival instinct, plus environment, plus connection. But the nature of emotion remains misty as dawn. Perhaps it is a warning system. Perhaps it is how life learns to communicate. Or perhaps emotion is the color of consciousness. No one truly knows, but the listener senses one thing. In the journey of healing, emotion is the gentlest guide. Have you ever noticed an idea arriving at the oddest moment? While showering, while drifting to sleep, while staring out the window. When the mind relaxes, science has found that when the brain is not focused, the default mode network is most active, and that is where creativity is born. Creativity is not effort. It is letting go. Like snowflakes falling only when the wind is gentle, ideas arrive when the mind is soft. That odd moment, when you feel you have lived this before. No one knows why. Maybe it's a hiccup of short-term memory. Maybe overlapping neural signals. Maybe the brain rehearses ahead, like an AI predicting the next frame. Or maybe it is the brain's poetry, a reminder that life repeats more than we imagine. A sugar cube can reduce pain. An inert pill can slow the heartbeat. A phrase, "You will be okay," can trigger dopamine. Placebo proves. Belief can change biology. The body not only obeys pharmaceutical commands, it also listens to whispers from the mind. Sleep is not rest. Sleep is repair. Sleep is regeneration. Sleep is a nervous system reset. Sleep is the brain clearing toxins. Without sleep, we fall apart. Mind frays, emotion shatters, body collapses. Sleep is the oldest ritual life has ever known. Sleep is the medicine the universe grants to every creature. Science still does not have all the answers. Telomeres shorten. Cells stop dividing. DNA gradually damages. But why does the body decide to age? Some hypothesize aging is the price of evolution. Some believe it helps limit cancer. Some say aging is pre-programmed, a way for life to make room for the next generation. Humans spend a lifetime exploring the outer universe, but perhaps the hardest journey is returning inward. None of us have the answer, but each night, when we close our eyes, we step into the universe we carry in our hearts. The body is matter, but the life within it is a wonder. After guiding the listener gently through the mind's mysteries, dreams, memory, consciousness, the narrator lowers the voice another half-beat, like the story sinking into the most shadowy frontier of science, the border between living and dying. Humans do not only want to understand the universe, we want to understand the life flowing within us. From there, the conversation opens slow, profound questions the modern science can only bow to. Human lifespan, by current knowledge, seems capped around 125 years. Then the narrator asks soft, tender, but enough to evoke a vast contemplation. Is that a real limit, or only the limit of what we have seen? Our bodies age, cells tire, vessels slow, systems falter, but science still does not know. Why do we age? Why does the body decide to stop renewing? Why do some genes switch off with time? Some hypothesize aging is the price paid for developing intelligence. Some that lifespan limits allow faster evolution of new generations. Others propose the body could live much longer, but we have not found how to switch on that potential. No one knows where the boundary of lifespan lies. Perhaps it does not lie within the body, but within the mind, in how we understand time and life. Lifespan is not a fixed number, but an open question, a secret the body keeps. There are species that live so long human life seems small. Galapagos tortoises até 180 years. Greenland sharks to 400 years. Deep sea clams to 500 plus years. Bristlecone pines over 4,800 years. Ancient corals, 10,000 years. And even in freezing seas, the immortal jellyfish can revert to youth and begin its life cycle anew. Time is unfair, but not malicious. Each species simply lives as its body allows. Science still does not understand why some species barely age. Some possess near-perfect DNA repair mechanisms. Some have metabolism so slow time seems to halt. Some continuously regenerate cells without error. Some seem to not know what old is. And that is what makes this planet silently beautiful. Each creature carries a different version of life. Humans see lifespan as a straight line, but in nature, it is a song with endless melodies. When life rewrites itself, here, the tale becomes almost magical. A starfish, cut off an arm, still moves slowly in the blue sea. Weeks later, the arm grows back, as if never lost. Then the salamander regrowing limbs, tail, eyes, spinal cord. Then the flatworm regenerating an entire body from a tiny fragment. Then deer growing a new pair of antlers each year from bone. In nature, death is not the period at the end. It is merely an invitation to begin again. End quote. Science knows regeneration occurs in several steps. Cells revert to stem-like states. The body activates repair genes. Tissues remap themselves. But the greatest question remains unanswered. Why can only some species do this, while humans cannot? We have stem cells. We were once an embryo, able to form every organ. We still renew blood, skin, organs every day. But when major damage occurs, the body does not regenerate. It scars. It would trade regenerative power for a more complex brain? Or is the body reserving that power for something we do not yet understand? The question floats like a feather, falling on the listener's consciousness, silent but leaving a strange feeling, as if they hold an ancient secret inside. After speaking of lifespan, immortality, and regeneration, the narrator lowers the voice, another notch, whispering, blending with the music like thin mist. Though science does not yet understand everything, one thing is certain. Your body is a story written across more than 4 billion years. Each cell carries the memory of creatures that lived before you, creatures that could regenerate, live centuries, and outlast death. Perhaps the only true immortality is not the body, but information, memory, passed through generations. The story of life linking the deep sea to the age of dinosaurs, from primeval forests to you. You are the result of miracles science still cannot explain. Walk gently with me, for the unexplained stretches as wide as the night sky. Humans do not merely evolve biologically, we evolve in the stories we tell. After reflections on lifespan, regeneration, and the mystery of living beings, the narrator gently shifts direction as a guide leading the listener out of the biological forest into the wide plain of human behavior, culture, and collective soul. Humans are made not only of cells, but of collective memory. of the stories of our species, of the things we believe, and the things we do not know why we believe. And thus the journey enters a new mystery. One science still fumbles at like a child first touching the world. Language is among humanity's greatest wonders. Yet science still cannot answer the seemingly simple question: where did the first speech arise? No one knows the exact moment when broken sounds became meaning. No one knows why the human brain developed areas specialized for language. No one knows why ancestral silence blossomed into stories spanning millennia. Some hypothesize language arose from group living to warn of danger. Some say it started as song, as lullabies, as the need to connect. Others suggest language emerged spontaneously, like birds' flight patterns self-organized, needing no architect, just harmony. One day long ago, perhaps someone uttered a sound, and another understood. That understanding spread, and the world was never the same. Language, something we use daily, almost unconsciously remains an unsolved problem. And the most beautiful thing is, when you hear these stories, you carry within you all the history of human speech. No theory fully explains why we laugh. Laughter does not help survival. It does not make us stronger. It does not make us smarter. Yet infants laugh before they can speak. The congenitally blind, never having seen a smile, still laugh. Primates also display a laughter-like play response. Laughter seems ancient, beyond culture and language. Some scientists say laughter signals all is well. Some that it is the brain's pressure valve. Some call laughter the release of cognition when we perceive paradox. Maybe we laugh because we want to live, because a smile is the way the soul breathes. Science sometimes can only stand and watch, unable to explain yet bowed before the beauty of the simplest things. Music intangible, not feeding the body, not protecting us from danger, can make us cry, tremble, remember what we thought forgotten. Why? Science still does not know. Some suggest music is an extension of language. Some say rhythm echoes the heartbeat in the womb. Some propose music awakens evolutionary memory of community, ritual, connection. Music is how the mind touches what cannot be spoken. Perhaps music was humanity's first speech, lullabies, drumbeats, footfalls in the night. And so we do not hear music only with ears, but with something deeper, ancestral memories sleeping in our blood. Love, what makes humans change, dare, sacrifice, hope, and heal, is one of science's greatest mysteries. Love has no formula, no logic, no law. We do not love because it is optimal, not because it is most necessary, not because it is rational. We love because we love. Maybe pheromones, maybe childhood memories, maybe a sense of belonging, maybe safety, maybe insecurity. But whatever the reason, science can only observe the phenomenon, not touch its essence. Love is something the brain does not need for survival, but the heart cannot do without to live. And in the silence we understand. Love is the most beautiful mystery we need not explain. Animals shed tears for physical pain, but only humans cry for sorrow, joy, love, memory, loss, overwhelming beauty, or because words fail. Tears of emotion are a uniquely human trait, but no one knows why they evolved. Maybe tears signal a call for help. Maybe they release stress hormones. Maybe they're the body saying, I need an embrace. Tears might be the earliest language of empathy. And we understand, tears are not merely weakness. They are a certificate of humanity. When human minds share a dreaming ground, the narrator says that from the Greeks to the Maya, from Vietnam to Northern Europe, from Africa to Pacific Islands, civilizations that never met, yet have strikingly similar stories. Floods, giants, world trees, dying and returning suns, souls ascending to the sky, humans arising from earth, water, or light. Why? No one knows. But one hypothesis is that they all stem from the same brain architecture, the same storytelling instinct, the same fear of darkness, and the same hope for protection. Perhaps myth is the way humans explain the intangible, and on a quiet night, myth still whispers within us like humanity's memory sleeping deep in the marrow. In nature, the strong often live for themselves, but humans are different. We cooperate, share, build, trust strangers. Biology should have pushed us apart, but humans drew closer. Science calls this an anomaly, an unusual phenomenon, but that anomaly created art, science, societies, religions, language, civilization. No one knows why the brain evolved toward extreme cooperation. Humans were not born to live alone. Cooperation is the miracle that helps us survive the dark. A cycle of intellect and fragility. Why did great civilizations once arise and then disappear? Egypt, the Maya, Mesopotamia, Harappa, Easter Island, all once radiant, then gone. No single cause is known. Climate change? War? Famine? Disease? Shifts? In trade? Or simply time? Perhaps no civilization truly dies. The narrator says, it only transforms and blends into the next. Like stars that die to create elements for the next generation, societies too do not vanish. They change form. We have traveled through the mysteries of the body, then of mind, and now of society, culture, and the collective soul. All of these are open questions, and it is that not knowing that makes humanity beautiful. And finally, when we ask about the universe, life, and the brain, we are actually asking about ourselves, and the biological restlessness, the spiritual longing. The first question rings like a deep, low note. Why do humans want to know everything? In this universe, there are many species that live without asking why the sun rises. They do not ask where the universe began, do not study physical laws, do not write music, do not paint, do not ask the meaning of life. Only humans do. For science, this is a paradox. Curiosity seems to transcend mere survival needs. We do not need to understand the Big Bang to survive tomorrow. No need to know black holes to find food. No need to analyze DNA to love someone. So why do we ask? Some scientists say curiosity is a byproduct of overdeveloped intelligence. Some philosophers claim curiosity shows the human soul never sits still. Some neuroscientists say curiosity is how the brain rewards learning every answer, like a gentle stroke. Maybe humans want to know everything, because within us is a piece of the universe wanting to look back at itself, a long silence calm as a midnight lake. We are the way the universe asks questions about its own existence. And the listener feels, somewhere in the chest, a small light stirring, because story is the language of being. As the first question settles like fine sand, the next is posed. Why do we tell stories? Why have humans, since drawing on cave walls, created myths, legends, poetry, and written records? Science still cannot fully explain the power of storytelling. Stories do not feed us. They do not protect us from predators. They do not make us faster or stronger. Yet humans tell stories to understand the world, understand each other, understand ourselves, heal pain, connect with the dead, pass on the sacred, preserve memory. build the future, keep beauty that time tries to erase. Stories are where humans turn chaos into meaning. Without story, everything is data. But when told, it becomes life. Storytelling is how humans find their way home. A home not of geography, but of spirit, where we recognize that every joy, every sorrow, every wound, every miracle is worth keeping. Because mystery is the space where imagination breathes. The third question rings like the universe's final lullaby. Why are unsolved things so attractive? Because the unknown is where human imagination is free. If everything had an answer, the universe would be a bare room, fully lit, no shadows, no folds, no place for dreams. But the universe and life is full of darkness, vagueness, regions no one understands. Those gaps make the human mind move. We look at black holes and imagine. We look at stars and hope. We look at the darkness within and write poems. We look to an unclear future and keep living. If everything was certain, there would be nothing left to search for, nothing to call beautiful. Mystery is the cradle of knowing, where every piece of knowledge begins and where imagination is allowed to grow. And in that ambiguity, humanity finds what science cannot place in an equation: the divinity of not knowing. We traveled the mysteries of the universe, of galaxies, of Earth, of life, of the brain, of love, and of civilization. And now, we come to the mysteries of curiosity itself. What makes us human? Perhaps we were not made to know everything, but we were made to ask, to seek, to listen, and to tell, for it is the question that keeps the flame alive. Mystery is not the thing that frightens us. Mystery is what makes us beautiful. We have just traveled a very long journey, a slow breath, like the universe breathing as night falls across distant galactic ribbons. You have quietly touched with me the 100 greatest mysteries of science, questions that open like doors, things unanswered, things still waiting to be understood. And it is precisely those, the unexplained, that make this world so beautiful. Not every question needs an answer tonight. The narrator continues, for life is not built of certainty. It is built of mystery, of the spaces for imagination to breathe, for hope to germinate, for the soul to find the softness daytime often strips away. The world is larger than we think, the universe stranger than we know, and you are deeper than you ever imagined. Now, let your eyes slowly close. Do not try to seize any mystery. They do not demand answers. They only invite you to rest. And let yourself fall into sleep. Embrace the wonder of the unknown, like a child holding the night sky without needing to understand it. Good night. Sleep light as a star falling on water. The universe will watch over you tonight.